Hi students, this is Alex here. In this video, we are going to discuss about graph in discrete mathematics, the definition of the graph and basic terms of the graphs and different types of the basic graphs with examples. When we say graph, it is represented by G and it is having vertices and edges. So the graph consists of vertices and edges. Vertices are nothing but points. Suppose if I have 2 points and if I name this as V1 and V2, these are the two vertices. And if these two vertices are joined, then it is called as a edge. Suppose if I name this as E1, this is edge 1. I may have any number of vertices. Suppose this is another vertex V3 and I can also join these two, I get edge 2. So in this way a graph consists of set of vertices and edges. And when we say G is V comma E and these edges need not be a straight line always. It can be short, it can be longer, it can be curved, it can be in any form. So I give another example. Suppose if I have V1 and V2 and these two are connected to get the edge. So I can have something like this. This is edge 1. In the same way, if I have V1, V2, I can also have a edge like this. So this is E1. So it can be a curved, it can be shorter, longer, or it can be in a straight line. Now let's see what is meant by adjacent vertices. The term adjacent vertices is nothing but any pair of vertices which is connected by an edge. For example, if I have vertex V1, V2 and if this is connected by the edge, then this pair V1, V2 is known as adjacent vertices. In the same way, if I have another vertex V3 here which is connected by the edge, suppose this is edge E1, this is edge E2. Now V2 and V3 are connected by the edge E2. So we can say the pair V2, V3 are adjacent vertices. Suppose if I have another vertex V4 here which is connected to V2 and if I name this as edge E3, so this V2 and V4 is connected with the edge E3, so this pair is known as the adjacent vertices. And here there is no connection between V1 and V3. So we cannot say V1 and V3 are adjacent. So these pair of vertices which are connected by the edge, so we call these as adjacent vertices, whereas V1, V3 and V1, V4, so these are all not connected by any edge, so they are not adjacent vertices. Now let's see what is meant by adjacent edges. So adjacent edges are nothing but the two edges which have a common vertex. Suppose if I have one edge like this which is connected by the vertex V1 here and V2 here, and there is, let's name this as E1, this is edge 1, and there is another edge which is connected by the vertex V2 and V3. This is our edge 2. So these two edges have a common vertex V2. So we call this as the adjacent edges. So here we can say E1 and E2 are called adjacent edges because they have a common vertex. In the same way, if I have another vertex V4 and this is our edge, this is our edge, and let's name this as the edge E3. Both E2 and E3 have the common vertex V3, that is E2 and E3 have a common vertex V3. So we can say these two edges have a common vertex, so they are adjacent edges. But if I consider E1 and E3, they are two different edges but they don't have a common vertex. So E1 and E3, we cannot say they are adjacent. If two edges are adjacent, they should have a common vertex. Next we are going to see about the isolated vertex. So isolated vertex is the one which is not connected by any edge. For example, if I have vertex V1, vertex V2, vertex V3 and vertex V4. Suppose if these are connected by the edge, this is the edge E1, this is the edge E2 and this is the another edge E3, but this vertex V3 is not connected by any edge. So this vertex V3 is known as isolated vertex as it has no edge. Next we are going to see about the label graph. Label graph is the one in which each vertex and edges are assigned a unique name. For example, if I take a graph where these are the vertices and these are connected by the edges like this. This is a graph, but these vertices and edges are not assigned any name. The same thing, if I have given a name or assign a label, this is the vertex 1, this is the vertex 2, this is vertex 3, this is vertex 4, this is vertex 5, and this is edge 1, edge 2, edge 3, edge 4. So comparing to this graph, what I have done in this graph is we have assigned a unique name for each vertex and edges in this graph, and this is known as the label graph. Next we are going to see about the directed graph. So directed graph is the one in which we represent the edge by direction. For example, suppose if this is vertex 1, this is vertex 2 and this is vertex 3. Suppose if I join these, this is edge 1 and edge 2. We name this as edge 1 and edge 2. We have edge 1 which is having a pair of vertices v1 and v2. Suppose if I represent its direction, that is edge 1 is incident on v2, the vertex v2. In the same way, if I give a direction for the edge e2, that is this edge e2 is incident on the vertex v3. So we give a direction. So the graph in which every edge is directed is known as the directed graph. And suppose if the edges are not directed, then it is undirected graph. We can take the same example. We can give the same example like taking the vertex v1, v2 and v3, and we have the edges e1 and e2. So we name the edges e1, e2, but we are not giving any direction. So we see here every edge is undirected. So we don't have direction. Which edge is incident on which vertex. So such a graph is known as the undirected graph. We also have mixed graph in which some edges are directed and some edges are undirected. Again we go for taking a same example. We have vertex 1, vertex 2 and vertex 3, and we have the edges e1 and e2, and let's name this edges as e1 and e2. Suppose if I give direction for the edge e1 but I did not give any direction for the edge e2, then this is a mixed graph, because e1 is directed, the edge e1 is directed, it shows a direction where the edge e1 is incident on the vertex v2, but the edge e2 is undirected. We don't know whether the edge e2 is incident on v3 or v2. So this is called as a mixed graph. Some of the edges are directed and some are undirected. Next we are going to discuss about loop. Usually an edge is a one which is connected by two vertices, but loop is a one in which an edge is connected with only one vertex. Suppose if this is the vertex 1 and loop is the one in which there is an edge which is having the starting and ending with the same vertex. So this is the edge E1, but this is having only one vertex. So we can see another example where we take vertex 1, vertex 2, vertex 3. Suppose if this is connected with V1 is connected with V2, let's take this as edge 1, and let's take these two and name it as E2. V1 is connected with V3 and this is edge 2. But there is another edge which is having the starting and ending vertex as V3 only. This is edge 3. So this is called as loop. We can see here this E1 and E2 are connected with two vertices, but the edge E3 is connected with only one vertex. So we can see the edge of a graph which joins a vertex to itself. It means it is connected with only one vertex. Next we are going to discuss about the parallel edges. So parallel edges are nothing but an edge which is having this, which is connected to the same vertices. For example, if I have V1, V2, and if this is connected with edge E1, and there is another edge which is connecting E1 and V1 and V2. Let this be E2. So here in this case we call E1 and E2 are parallel edges. So we see here the edges having same pair of vertices. We can take another example. Suppose if we have V1 and this is V2, this is V3 and this is V4. Let's take lot of edges. This is the edge E1 and this is the edge E2 and this is the edge E3 and there is another edge E4. Let's take another edge E5 and we take another edge E6. So if I see the edges E1, E3, E4 all are connected with the same pair of vertices. So here we can say E1, E3, E4 are parallel edges. In the same way, we can also see here this E2 and E5 are connected with V3 and V4. We cannot say E1 and E2 are parallel because they are connected with the different vertices. So here we can say E1, E3, E4, then E2, E5, these are all satisfying this condition, that is edges having the same pair of vertices. But if I take E1 and E2, here it appears parallel, but they are not connected with the same pair of vertices. So they are not parallel edges, but the edges which are having the same pair of vertices are known as the parallel edges. Next we are going to study about the simple graph. The simple graph is the one which does not have any parallel edges or loop. For example, if I take V1, V2, then V3, and if I connect this with the edges, and if I name the edges as E1, E2, E3, in this graph we find there is no loops present or no parallel edges present. So loop already we discussed, which is connected edge connecting with the single vertex. So there is no such thing present, and parallel edges having the same pair of vertices. So we don't find anything as such. So this is known as the simple graph. Next we are going to see about the multigraph. So multigraph is the one which is not simple. It means it will have some parallel edges and loops. For example, let's take vertex V1, vertex V2, vertex V3, and if these are connected by the edges, let's name the edges as E1, E2, E3, and there is another edge which is E4, like this. So this is E4, and there is another edge which is connected only with V3, So this edge, let's name it as E5. So here we find parallel edges and loop. So such a graph which contain some parallel edges and loops are known as the multigraph. Already we discussed about simple graph, but next we are going to discuss about the simple directed graph. So it is a simple graph in which the direction is given for the edges. For example, if I have vertex V1, V2 and V3, and if I join by the edges E1, E2 and E3. Let's name this as E1, E2, E3. And if I give a direction, edge E1 is the one which is incident on the vertex V2, and edge E2 is again incident on the vertex V2, and edge E3, let's take it as it is incident on the vertex V1. So like this we give a direction. It is a simple graph in which it is direction is given. So it is known as a simple directed graph. So it is a simple graph which is directed, that is direction is given. And we also should notice that simple graph means it will not have any parallel edges or loop. So there is no parallel edges or loop present. So it is a simple graph in which direction is given for the edges. Next we are going to see about underlying simple graph. When there is a graph with multiple or parallel edges and loops. For example, if I have V1, V2, V3 and these are the vertices, and we have edges like this, we have another edge and we have another loop, that is also an edge. So let's name this as E1, E2, E3, E4. We have 4 edges. Suppose in this we delete the parallel edges and loop, then the remaining graph will be vertex V1, V2, V3 and the edges E1 and E2 will be there as it is. Let's take this as E1, E2. But we deleted E3 and E4 because this is parallel edge and this is loop. So such a graph which is obtained by deleting the parallel edges and the loops are known as the underlying simple graph. Next we are going to study about underlying undirected graph. Suppose if we have a multigraph or any graph which is directed, let's take an example V1, V2, V3 and let's connect with the edges and let's also take parallel edges and let's also take a loop. Let's name this. This is E1, E2, E3, E4, E5 and it is directed. Suppose E1 is directed in this way, E2 is directed in this way, E3 is directed in this way, E4 is directed in this way, E5 is directed in this way. Suppose if this is a graph given, in the same graph we are going to remove all the directions. So we redraw the graph again. We have 3 vertices and we have edges and we have loop and the parallel edges, and let's name this as E1, E2, E3, E4, E5. So what we have done is we have removed all the directions. So what we have done is from the directed graph we ignored all the directions of all the edges in the given graph, and the remaining graph what we get will be undirected, and such a graph is known as the underlying undirected graph. Next we are going to see about the weighted graph. So weighted graph is the one in which every edge is assigned some weights. Weights are usually a numerical value. Suppose if this is our graph where we have vertex V1, V2, V3, V4, and we have the edges E1, E2, E3, something like this. Let's name this edges as E1 here, E2 here, E3 here. Along with that, we are also going to give some weights, like for this edge E1 it is W1, this is W2, and this is W3. So for every edge the weights are assigned. Such a graph is known as the weighted graph, and these weights are nothing but the numerical values. Next is pseudographs. Pseudographs are the one, a graph with multiple loops and multiple edges. For example, we take vertex V1, V2, V3, V4, V5, and suppose if these are connected with the edges like this, and we also have a parallel edges, many parallel edges, and also we have many loops. So let's name this edges E1, E2, E3, E4, E5, E6, E7, E8, E9, E10, and this is E11. So here we find, so such a graph which contains many loops and parallel edges are sometimes called as a pseudo graphs. Next we will see what is finite graph. A graph which is having the finite number of vertices and finite number of edges, that is known as the finite graph. Now let's see some basic terms of the graph, that is order of a graph. So we know a graph consists of vertices and edges. So if we calculate the number of vertices, that is known as the order of the graph. So number of vertices is nothing but the order of the graph. And there is another term called size of the graph, which is nothing but the number of the edges equal to size. For example, if we have a graph, we have the points, that is vertices, and if this is connected, suppose if we count the number of vertices, let's name this as V1, V2, V3, V4. So there are 4 vertices. So the number of vertices, it means the order is 4. The same way, if I see edges E1, E2, E3, so the number of edges is the size. It means the size is 3. Next we are going to see about the another basic term, multiplicity of a graph, that is denoted by m. Suppose if I have vertex v1 and v2 and we have edge e1, then we can say the value of m, multiplicity of this edges, this ordered pair v1 and v2 is 1. Suppose if I have v1, v2 and I have the edge e1 like this and I have another edge e2. So this is e1 and this is e2. So in this case the multiplicity is 2 because this pair of vertices is connected with 2 edges. So in the first case we had only one edge, in the second case we had 2 edges. So the multiplicity is 2. We shall take another example. Suppose if I have v1 and v2 are the two vertices. Suppose if I have edge e1, then another edge e2, then another edge e3, then another edge e4. So totally we have 1, 2, 3, 4. I have given the direction also. So the same pair of vertices is connected with 4 edges. So the multiplicity is 4.